Hello, everyone. It is really great to see all of you here for this Heidelberg AI event with Professor Seong from the University of Tübingen. And he will talking about general AI in the private world. For those attending the first Heidelberg AI event, we are a student-led event series for enthusiast students and researchers with the aim of letting them exchanging ideas and get to know each other in the area of Heidelberg. We are part of the larger Heidelberg AI ecosystem, and we collaborate closely with the LS Unit Heidelberg, the NCT Data Science Seminar, and Helmholtz Imaging. And Heidelberg AI is part of the German Cancer Research Center, and here you can see all of the organizers. Now, getting back to our speaker, Professor Seong studied mathematics at the University of Cambridge and received his PhD at the Max Planck Institute for Informatics under the supervision of Bernd Schiele and Mario Fritz. Afterwards, he worked at Navia AI Labs and is now professor at the University of Tübingen, where he's leading the group on Scalable, Trustworthy AI. And further, he is deeply involved in the research trends.ai, where he also hosts an event series I can only recommend to join. And with this, without further ado, and a warm round of applause, I hand over to Professor Seong Oh.
Thank you for the great introduction. I'm honored to be here in the talk. I hope the talk is interesting to all of you. And my understanding is the question is also kind of delayed to the end, right? So please, if you have any questions, write them down and feel free to ask at the end. And can I ask quickly, like how many minutes I have for the talk? Just to check again.
You have 40 to 50 minutes.
Okay, excluding the Q&A, right? Or including?
Ye yes, excluding the Q&A.
Okay, I'll try to make it like 30 minutes, slightly over 30 minutes, so we have potentially more time for discussion, hopefully. Okay. So I wish to start with this first slide on AI wins gold medal at IMO. The previous version of this slide was with AI wins silver medal at IMO. So there's been a change. It's kind of a monumental moment for the AI to kind of beat apparently the hardest kind of competition, most intellectual kind of competition in humanity. But on the other hand, I try to use LLM for kind of replacing my tedious tasks. So as I try to kind of organize events using research trained AI, for example, I was kind of sending out invitation emails to like hundreds of people to give a talk at an event like this, right? And I use LLM for that. So when there's email coming in, there's a backend which is reading the emails and then auto-generating the responses. And there were tons of cases where it failed. So if you read this email, it says something like, unfortunately, it seems there was a misunderstanding. You cannot actually come to the event. But this is actually wrong, right? There were free spots and they could just join the event. So I was immediately following up with an apologies email saying, "Oh, there was an LLM speaking, and that was not me. Sorry, you can actually come to the event." So LLM is not completely replacing me, even though they are actually solving IMO problems so well. So here comes my kind of research interest and my eventual goal in AI. So it's quite grandiose, right? Let AI truly benefit humanity at scale with minimal side effects. But this is also what AI is supposed to be doing, right? So I would say the goal is rather aligned with what many others are trying to do. But here comes the kind of the slightly different angle that I wish to take, which is to kind of address problems that are more specific to my interest, Asian population, productivity decrease that comes from Asian population, and making sure the the society is still productive with more kind of shift in the demographics, for example, and how to kind of take care of the health for the older generations and so on. So I wish to kind of take a look at how the current general AI is kind of getting there in terms of increasing human productivity. There's been quite some changes in the last couple of years, but also some of the consensus that we are seeing in 2025 is that it's kind of reaching some plateau. There's a hard limit given by the so-called fossil fuel of AI, which is the data or web scale data like um, public data that can be used for training the pre-training the models. Um, and now people say, yeah, it's the time for post-training. We should probably focus more on scaling, test time scaling, for example, finding new usage of models in kind of using new tools and kind of attaching this to new kind of agentic systems, for example. Yeah, so that's kind of the current status. The problem with AI for now is that it's a general system that actually does not solve your problem. So the generalist AI is perhaps very good at mathematics and coding, which is very good. I'm also using Cursor on a daily basis. But when it comes to your problem that you have to solve in your daily life, it doesn't really solve it. Um, my research interest is kind of surrounding these three bullet points. One, AI is not doing well because it's not very good at communicating or understanding your intent. And two, we humans do not understand the system very well. Yeah, so this is about explainability. And three, you need to apply this eventually to security, privacy, sensitive cases in order to be useful, right? But there's no guarantee that your privacy or system security is guaranteed within these kind of application scenarios. Um, so the goal is to close the gap in those three directions. Um, so the so the talk today will be based on these three challenges one by one. Um, the first challenge, as I said, is kind of making sure AI understand my intent. So I'll go a little bit deeper here and kind of try to give you some overarching kind of theme that I have about human AI communication. Um, so still kind of humans' way of communicating to AI, what they need is quite cumbersome. Let me give an example in kind of drafting investment portfolio. Um, if the user want the AI to come up with a investment portfolio, they need to say, of course, this sentence, but on top of that, they also need to say what kind of market they can actually buy securities, right? And what's your age and income? These are kind of personal data which kind of shape your risk appetite. And eventually, what matters is whether you should always be able to liquidate the money or whether it's okay to put the money in some less liquid securities. Yeah, so all of these are kind of very important for A to make a decision about what kind of investment portfolio will be ideal for this user. But user, when they have to ask this, they do not come with all these questions, right? Um, but before the current age of AI, where after ChatGPT, right? So before ChatGPT, the usual communication medium for letting AI understand your need was data. So the typical workflow was as follows. User defines a task and typically goes to a set of annotators and say, yeah, here's unlabeled data. Here's the task, and you have to supply the labels. And then the annotators, of course, understand the task and kind of do the simulation of the task and generate a lot of outputs like classifying an image, for example. And then training data. is formulated based on these pairs of data and label. And the machine learning model is eventually going to understand what task this user wants based on the patterns of inputs and outputs, and just try to mimic the input to output mapping. And that's kind of the traditional way machine learning is done. Um, it works pretty well, but it kind of suffers from spurious correlations because if you just give data, then you can also miss out some corner cases, right? And typically these corner cases are causing problems with shortcut learning, for example, and the model does not understand your intention fully well. But now comes the era of instruction-based communication. So instead of having to provide all kinds of data to let the model understand what you want, you can just say it in English, right? So when you want your model to answer emails, just give the email that you get, and you just give some additional instructions in system prompt or user prompt, and the model figures out what to say in the response. So this is much more handy. But this is also problematic in practice because it only makes sense for one-time task, if you think about it. So people do prompt engineering, but when you try to use this kind of instruction-based model intention, like intention communication, the typical problem that you encounter is you still need some evaluation to make sure your prompt is good enough, especially when you have to kind of upgrade your prompt from version 1 to version 2 and so on. You still need some kind of verification if version 2 of your prompt is better than version 1. And the typical way you do that is by still collecting some labels, right? Some data set where you have the ground truth. So you can test if the instruction is actually making the model get better scores on this benchmark. And so even with this prompt engineering perspective, you still need some labeled data. And that's kind of pulling you back to the traditional kind of communication mode of providing data to kind of communicate with the model. I mean, you're not using data directly to train the model, but still, we need data to kind of validate if the instructions are working well. So I feel like we are not kind of moving forward so much with instructions capabilities. And to me, the question is, what is the next medium of communication between AI and humans? So that's the main kind of thoughts that I have these days. And the solution that I tend to believe in is more about modularity. Um, so modularity means you break down a bigger problem into smaller subproblems and hope that much of the subproblems are actually transferable and reusable in multiple different scenarios. So when there's a new human task where the human user has to kind of encode the intention in some way, what the model can just figure out is not to train any parameters or come up with a new kind of prompt to instruct itself, but just do some selection of the modules to complete the task. Yeah. So in a sense, it's kind of doing some pre-computation or pre-adaptation of the individual modular components. So you prepare a lot of different basic components that is probably useful for, let's say, 90% of the task ever. And then you just need to do a very little minimal amount of computation on top to kind of build the whole system by connecting all these ingredients. And I think this is something that's emerging in agentic AI paradigm as well, where you're kind of assigning multiple different agents, different dedicated roles, and you just form a society of these AI systems to kind of accomplish some task. Yeah, so this is generally the approach that I think has more future. And this is also what recent paper from NVIDIA was kind of calling for. Current LLMs are a little too heavy, and we can probably break down the bigger problem into smaller ones and just combine these to tackle new problems. I also wanted to kind of briefly mention about some of our work on modularity before we are quite serious about kind of coming up with more diversified agents or diversified models. When taken together, they are kind of forming some interesting properties or understanding, like measuring how diverse different models are. Um, and so this work is about, for example, the landscape, the loss landscape of neural networks. And if you're familiar with the linear connectivity or mode connectivity paper, they say there are some simple structures in the solution space of neural networks. And based on this property, they were able to build some non-trivial ensembles that are not just built by training a bunch of models from random initialization, but also from a set of points in the parameter space that are trained together. So instead of training a single point in the solution, in the parameter space as a solution, you are training a solution set of points, and uncountably many solutions in the solution space, in the parameter space. So I found this topic super fascinating because that's a way to also come with a bunch of models that are potentially diverse. And then we try to kind of extend this idea to kind of in the original paper, they were able to find a um, combination of two line segments as a potential solution set um, in the parameter space. But we extended the idea to a star domain where we do not have a single combination of two segments, but also like n different combinations of n segments, right? So there's a central model there, and we can kind of find kind of lines that are all intersecting at a single point in space. And all the solutions that are along the line are basically solutions. Good, like you're achieving very low loss value along all these solutions. Yeah, so we were quite fascinated by this kind of structure in the solution space. And we thought, yeah, this is potentially a good way to come up with an interesting set of models at the same time. So coming back to modularity again, we have been working on kind of finding diverse solutions to a problem and potentially using that for kind of doing, let's say, uncertainty estimation as well, like OD detection based on this kind of diverse set of models. Assuming that when those diverse set of models are all predicting different answers, then it's likely that the sample was kind of out of domain. Yeah, because let's say when the sample was in the domain, then maybe all these models are basically trained on this data, and so they will probably answer in the same way. But when this is kind of out of domain, then the model has no kind of, it's heavily dependent on the initialization of the models. And so compared to in-domain data for these OD samples, maybe all these models are reacting differently. So that's kind of the use case of the modularity as well. So that was about the communication between humans and machines, and I think modularity is kind of hitting a good balance between, yeah, it's essentially potentially the most efficient way to encode human intentions to models, and we are putting a lot of efforts here. I wish to go a little bit quickly through challenge two, explainable AI, which is the other way around. So previously we were looking into kind of how humans are encoding their intentions for machine models, but it's the other way around now. So how can we make sure that machine kind of makes humans understand what they are doing? It's also kind of challenging because we've seen a lot of work on explainable AI, like feature attribution. Um, but in so many cases, we find it not so usable in practice because these are not actionable. It's going to show you, like in MRI scan, which part of the image is kind of causing the model to predict certain certain actions, right? Sometimes it really points to a very spurious cue, like some labels that are kind of at the rim of the image, containing the clinic information. But sometimes it's not so obvious just by looking at the heat map, right? What this model is doing. So instead of that, we are kind of trying to make a a more practical and actionable explainability methods. Um, as a solution for that, we are kind of trying to promote more training data attribution compared to feature attribution. Um, so feature attribution is exactly kind of trying to break down the model prediction back to individual features in the test data. Training data attribution is breaking down the current prediction into the training data itself. So because of which training data was this predicted? Why is the model reacting this way now? As you can see here, training data attribution is gaining more traction nowadays. Although in terms of absolute scale, it's much smaller community, but I see a lot of potential in this direction, especially with large language models. A lot of people are now starting to look into training data attribution. Again, training data attribution is quite actionable because it's going to tell you right away which training data is causing the problem or which training data is making the model succeed in this case, for example. And then it's quite obvious what you have to do to fix the model. If the sample is problematic, you leave that out. If the sample is helpful, then you add more. That's what I mean by actionability. It's also more interpretability because if you have spent a long time looking at those heat maps, sometimes the heat maps are quite obvious, but sometimes it's not so obvious if the heat map is somewhat uniform. And also many of the features are not super localizable as well, right? If it's something about the mood of the image, let's say, then the heat map is supposed to refer to everything on the image. Whereas if it's about training data, then it's going to tell you which training data, which is more discrete, and you have better understanding of understanding what the whole content of a data point is, and you probably understand very well why this data sample is causing problem and so on. And there's more room for improvement here. So I think this is quite exciting field to work on. So the goal for this section is to kind of encourage you to look more into this domain. So we have done a few work here, mostly on the human-centered perspective as well. So we are kind of criticizing the progress of feature attribution XAI for being so solutionism centric, right? Which means people will focus more on the mathematics part of it rather than kind of going out to the field and asking people, yeah, do you find it useful? Are you going to use it if I build it, right? So there's a lot of criticism from the human-computer interaction field about how XAI is kind of formulating their solutions. And so we are taking the approach other way around for training data attribution with our lab members here, which is instead of developing a solution and asking whether they find it useful, we first go to the users and understand their demands first, and then ask them hypothetical question. Okay, I'm going to build something like this. Are you going to find it useful, right? And that's what we did in this paper, actually. So we went to some practitioners like doctors and like employees at a company who's using AI on a daily basis, or model engineers, and then ask them, okay, we're going to build some training data attribution tool. Are you going to find that useful? Or what kind of extra features do you need for this technology? And they gave very interesting answers, and they gave so much insights. So, for example, we could propose to change the direction the whole TDA community is looking into. So the whole community is kind of looking into one-to-one attribution. So what happens if you remove one training sample on one test data? But everyone we asked about this, the usefulness of this approach said, no, that's actually not useful. If you have like millions of training points, who cares about removing one training point? Yeah. At least you have to consider, let's say, removing 1,000 related training data and see what happens as a result of removing this chunk of data. Maybe also on one chunk of test data, right? With similar kind of scenarios. So that's kind of the overall direction that we are proposing in TDA community. And we're still working on this. And I encourage a lot of you to um, jump into this area and contribute more. Um, and I wish to spend a little bit more time for challenge three, safe and compliant deployment. Um, the way I can imagine AI can increase your productivity on your daily basis. So, for example, mobile phones have increased your productivity, but I feel like AI is not there yet, not there to really help you like have 2x or 3x productivity. Of course, for coding, it's actually doing very good job. But for, let's say, booking an Airbnb place, right, for my vacation, I still need to do the same thing, and I do not use AI yet for doing these kind of things. What's the reason, right? Because if you want to make the AI do the um, flight ticket booking or hotel booking, Airbnb stuff, you have to give, at least for me, I do not feel like giving out all my credit card numbers and my personal data because I don't trust that the model is gonna have a good control over all this data, right? So when you have these kind of personal agents, the typical workflow is you put a lot of your PII in context, actually. And then the model will be connected to all kinds of tools on the web. Sometimes the model even decides itself what kind of tool they wish to use on the web. So it can totally be possible that the model can also just connect to some. Of course, you have a control over what kind of tool you can allow the model to use, but sometimes maybe in some free text form, you're sending out your credit card number or even your name and birthday, and that could potentially leak my sensitive data. So I don't really trust it yet. And to me, that's kind of one of the biggest hurdles for AI to be really useful for increasing my productivity. For it to be useful, right? I think some of my private data has to be in context. And there's, I think, some trade-off that we have to kind of take in for now. So here's some set of work that we have done so far. Maybe I'll skip the first two and talk about third one, data compliance, uncertainty estimation, conversational SEO, and contextual privacy. I'll skip these ones. Um, so data compliance, what about data compliance? Um, you probably know that OpenAI, Anthropic, mostly these two companies face a lot of litigations nowadays because of their usage of some proprietary data. Um, yeah, New York Times, who else? Some publishing companies, right? So that's because they're scraping data from the web, and there's no kind of guarantee that you're completely free of licensed data and so on, free of non-licensed data, I mean. So, so the technique from the machine learning side that can be used for inspecting the use of some proprietary data is something called MIA. It's the abbreviation for Membership Inference Attack. So here the question is, let's say you're New York Times and you have a bunch of articles, and you want to make sure you want to understand whether OpenAI models, ChatGPT, is trained on this data. The typical way people have done so far is to kind of give a chunk of data from your database to the model and see how the model reacts. If the way model reacts to this data is different from the model reacts to some other kind of data sources, then we kind of understand that, yeah, the model has probably learned on this data. Because the model, let's say the model loss or model prediction of the likelihood on this data is low, which means the model has probably been trained to have low loss values or high likelihood on this data. And so that's very indicative of the model having seen this data. So this kind of methodology has worked so far on vision models mostly, but not so much on LLMs actually. So the typical kind of understanding in the LLM community was that membership inference attack is potentially useful, of course, for kind of understanding the use of training data, but it doesn't work. And then here's our work saying, yeah, actually, it doesn't work, of course. Yeah. And that's because you have been looking into sentence levels or paragraph levels. As soon as you go over paragraph and sentence and enter into the domain of document level or even collection of documents level, then it starts to work again. That's because for text, if you look at a single sentence or some paragraph, there may still be a lot of similarities between, the same kind of paragraph can appear so many places, right? So even if you train on this, it doesn't really play a big role in kind of changing the model's behavior. But now with a whole collection of data points, if you supply this data to the model, then there may be all kinds of small changes that are not detectable per se on an individual level, on a paragraph level. But as you accumulate, yeah, it's still a little bit beyond the chance level, like 52%, let's say. And then those 2% difference compared to the chance level accumulates when you have like 1,000 times more data points. And they all contribute to kind of making a firm decision that whether or not this collection of data was used in the training or not. So that's kind of the intuition. And we argue here mostly that membership inference still works when you increase the scale. Yeah, that's kind of the main message. Um, Uncertainty estimation for language models. Yeah, so there are like two typical ways people like to get confidence quantification for large language models. One is to look at the likelihood, token-wise likelihood. So, for example, there can be a lot of things that you can do with the sequence of likelihoods, actually. So, let's say you generate this sentence. Sure, the capital of Chile is Santiago. And then this will generate an array of confidence levels. And you can also take a geometric mean or arithmetic mean or whatever you like here to eventually generate your final prediction of likelihood for the whole sentence. Yeah, so that's what people do. Yeah, in many cases, some others also do prompting strategies. So after you ask for this question, you ask again, okay, thank you, but what was your confidence? Answer in the range of 0 to 1. And then it's going to say, yeah, I'm actually 10% confident. And you take that as kind of the truthful quantification of its uncertainty. Yeah, that's what I mean by this, right? So after asking, you say, yeah, how confident are you? And then the model will say, I'm 95% confident. Um, but at the time, we thought maybe this is not good enough. I mean, these are obvious solutions, but can you do better? And we went for the solution of having a separate auxiliary model, which is kind of interpreting what this target LLM is doing. So you let the target LLM kind of answer your questions in some way, right? So you ask, what is the largest country by population? Germany. Um, and then instead of asking the same model, how confident are you? You let a auxiliary model observe the input-output patterns for this target LLM, and then infer the level of confidence based on these cues. Yeah, so this tends to work well. Well, of course, the question here is how to train this model because, there's no ground truth confidence. So for this, we take some approach of binning or clustering some of the questions, and then based on that, we estimate the average accuracy on this or average correctness, which is the accuracy for this cluster, and take that as the ground truth for every data point here to train this auxiliary model. So that is kind of the low level details, but eventually what this auxiliary model is learning is um, to be able to kind of estimate the level of uncertainty based on the input output patterns from the model. Um, I'm stressing this. So that's it for this paper actually, but I think this is a kind of nice um, kind of milestone for uncertainty estimation in LLMs. Because as I said at the beginning in the casual conversation as well, that it's not possible fundamentally, I think, for LLM to understand its own uncertainty. So I think fundamentally it's imperative that we have some auxiliary model or at least some kind of second pass over the model to infer the level of uncertainty. So for now, we have been looking to question and answer pair to understand the uncertainty, but probably you can also look into the array of logits, for example, for the model, and put some parameters on top of that to make predictions for the uncertainty. Or maybe you can even take a look at the internal activation patterns of the model. Or for reasoning models, I think maybe the reasoning trace can give some interesting insights about the true uncertainty of the model. So I feel like these are kind of interesting research directions that we should probably take regarding LLM uncertainty. Um, I can briefly talk about conversational search engines. So in another project, we've been looking into the economical impact of perplexity, essentially. So now people use Google a lot, right? But they also use Perplexity to get um, more convenient answers from the model, right? Instead of a list of websites, if you have a kind of clearly written text, which recommends, for example, the laptop that you wish to buy, then that's probably very useful. And of course, like as a product sellers, they wish to place on top of the others, right? In order to maximize the probability of kind of click-through rate. And so traditionally people have been doing SEO, and we are saying, yeah, now it's time for CSEO. That's not what we said, but what people in this community say. So, for example, they try to kind of use markdown formats for writing the articles, for example, and that's reported to be increasing the likelihood of ranking higher in these kind of perplexity outputs. So we did some sanity check if that is the case, actually. And we came up with the results saying actually see SEO approaches like changing the content to yeah, markdown or something, they actually do not work as well. So here's the zero line, which means there's no change in rank. And here's +1, which means there's one improvement in the ranking. And usually for CSEO methods that we have considered, it was quite extensive list of existing approaches that are kind of recommended in communities, and they do not work actually. So so this is the benchmark contribution, and we kind of make a message here that we should look into an actually useful CSEO approach to make it work actually. Um, Finally, there's work on contextual privacy. So that's kind of the example that I mentioned at the beginning, saying I don't want to put my credit card number in the context to kind of make it book my tickets, flight tickets. And we are also wondering whether, with the new development of reasoning models, are they handling my private data better or not? Um, and then we found that the reasoning models are also kind of leaking this kind of private information in so many different ways. So one way is accidental leak. So this is the kind of the thinking tokens, right? And sometimes they also leak something in the thinking tokens, which is probably not something that's supposed to happen. So there are some accidental leak that comes from the thinking tokens, or it's super easy for some adversary to come into the system and extract the personal data in the reasoning trace. So we kind of show in this paper that reasoning is not generally helping privacy, but it's actually exposing your privacy to a lot of other different dangers, potentially. So that's roughly kind of concluding the kind of work that I have done for the challenges part, where we focused on the security and privacy risks in applying AI for really productivity increasing kind of applications. So as for the future topics, I wanted to kind of give an overview of the potential directions that I think will be quite useful or fruitful in the future. We've been looking into privacy, IP protection, compliance, trustworthiness for LLMs, right, or vision language models, and I tend to believe there's going to be more question about privacy together with AI and agentic AI, which is also stressed in the first part of the talk. Yeah, we want to modularize quite a bit. AI's impact on humanity, of course, and AI nationalism, which is kind of strengthening nowadays. So again, I covered three topics today: communication of the intent, understanding of the system, security and privacy guarantees. Um, I also wanted to touch upon some of the future predictions that I wish to make. LLMs will be developed more open source. Actually, the OSS, the GPT OSS came out, so it's kind of outdated. But there are more companies joining this open sourcing of LLMs and foundation models. But I predict that data will remain private. The models will become more public, but the data will has been and will be private because it's so tricky to open source data. Um, and so I think the privacy of data will pose great opportunities for small companies actually, because I think the business model of kind of specializing in certain domain is still valid, especially with private data. Despite all these developments of generalist AI, I think there's a lot of value in still kind of adapting the generalist AI for your own problem and making it actually work on your problem super well. Um, and that is to be done by companies who possess data. Focus on scaling, focus on adaptation. I think that will be the kind of the focus for the coming years. Asians will continue to be important, in my opinion. Yeah. Nationalism. I think this is kind of self reinforcing trend. So as America is getting more nationalistic, I think Europe is also getting yeah, a little bit, right? And everywhere else as well. And I also wanted to kind of mention researchtrend.ai uh, that we are developing these days. So it's a website kind of showing all the daily digest as well as some of the talks that we host as well. So the previous talks are also visible on the website. So if you're interested, check them out. We also provide personal profiles. So please also check the website. The website is essentially just researchtrend.ai. So you can just type it in and go there. Thank you. And please feel free to come with any questions.